First thing we're going to do is take a look at those explicit formulas. So when you have an explicit formula, you've got your squiggly brackets, which we've all learned I'm not very good at drawing, of your sequence, because this is what we're looking at for a sequence, and I'm starting from 1 and I'm going to infinity. That's what all that notation is, all right? However, we are just going to write the first 4 terms. Okay, so here's our first one that we're going to look at. A sub n, oh my. Let's try that again, shall we? We have a sub n is equal to 1 over 2 to the n. All right, this tells me I'm starting at 1. So because n starts at 1, my first term here in this sequence is going to be a sub 1. Remember, an explicit formula is legitimately that. It's a formula. So I'm going to take this 1 and sub it into the formula. All right, so the explicit formula tells you where you start because math is all about notation, right? So I'm starting here when a is 1. So write that out, a sub 1. Then I'm going to take this 1 and plug it in. So this is 1 over 2 to the first power, which we know as 1/2. So a sub 2, same concept. First 4 terms, I'm going to take that 2 and plug it in. So 1 over 2 squared, there's 1/4. And we want the first 4 terms. So we've got 1/8, and plug in that 4 is 1/16. So of these terms, if I look at my ooh, that's a better one, isn't it? Oh man, I'm getting better maybe the more I practice. 1/2, 1/4, 1/8, 1/16. And I'm going to put ... on there. Oh, I've got plenty of room. I just didn't have it up there. Well, let's not smash this in so much then. 1/16. ... That is all you're doing. That's it. With an explicit formula, you legit just do the plug in. It's a formula that you're looking for. Okay, let's try another one here. Let's do example 1b. If I have a sub n is equal to -1 to the nth power times n over n squared plus 1, again, we're going to go the first 4. All right, so do it up. A sub 1, -1 to the first times 1 over 1 squared plus 1. So -1 to an odd power is going to keep it at negative, right? So I've got 1 over 1 plus 1, which is 2. Do the next one. A sub 2 is -1 squared times 2 over 2 squared plus 1, right? You're plugging that in for everything. So a negative number squared is positive, giving me 2/5. Do you see what's happening there? Okay. We're in Calc 2. We don't need to type all this stuff in. We know that this is now putting in a 3, making it odd. So I have, I now have -3 over, whenever I plug a 3 in here, 3 squared plus 1 is 10. This is what I am looking at you doing, right? You can plug this in. I was just showing you kind of how it worked up front. I don't expect you to write all that out. If it's helpful, great, whatever. Now an even is going to be positive again, so I've got 4 over 4 squared plus 1 is 17. So if I want to write out my first 4 terms here, I've got -1/2, positive 2/5, -3/10, and positive 4/17. Right? It is infinite because we have a sub n is going from 1 to infinity. So we put those ... dots at the end because I know that this is going to be an infinite sequence that we have. But there's our first 4 terms. Now, spoiler alert again. Anytime you have that -1, you know your signs are going to change, right? So your signs are going to change with that. That's actually called alternating. We'll get into that a little bit more later, but I'm just wanting you to be aware this -1 makes an impact, and we'll see that impact moving forward. All right? So explicit. You've got a formula, you plug it in. That's all there is to it. So we said there were two different types we were looking at, right? The explicit and the recurrence relation. So let's take a look at a recurrence relation. So here for our recurrence relation, again, it's a, oh my, let's try that one again. It's a sequence, and it's an infinite sequence. All right. And we want to, again, write the first four terms. So part A here is going to be A sub n plus 1 is equal to 2A sub n plus 1. And my first term is going to be 1. Remember, with a recurrence relation, you build on the terms. So you have to have an existing term so you can build on it, right? Okay. So let's do it right here. So whenever I'm looking at this, I'm starting at 1. So I have an A plus 1. That's where those match up. And if I have 1 to begin with, that's my first term. A plus 1, or part A sub 1 is 1. Now I'm going to take that and plug that in. This is 2 times 1 plus 1. I am taking this term and subbing it in, right? My current term, A sub n, plugging that in to get to the next term. See that? A sub n to get to the next term. A sub n, there's 1 to get to 2. Okay, just making sure. Probably just beating the same old drum, but at least you can see that. That gives me a 3. Then I take that value, 2 times 3 plus 1, because I'm building off of that current term, right? That's the purpose of the recurrence relation. You can't just randomly figure that one out. You have to do a recurrence relation. It's kind of like finding multiple derivatives, right? You have to have the first one to take the derivative off of it. Recurrence relation, you have to have that term so you can build off of it. That gives me a 7. So my fourth term will be 2 times 7 plus 1, giving me 15. Do you see how all that is? So then my first 4 terms here are going to be 1, 3, 7, 15. And we know it's infinite, so we put those 3 dots at the end to show it continues. All right. Okay, let's do another one. Again, first 4 terms. I have A sub n plus 1 is going to equal 2A sub n plus 1, where A sub 1 is negative 1. Pete and repeat. We're in a boat. Pete fell out. Who was left? Repeat. I don't know if you guys have heard that or not. Some people have, some people haven't. It's good stuff. Notice what I'm doing here. Exact same relation, but what's different? Instead of starting with a positive 1, I'm starting with a negative 1, and let's see how that plays out. That's what makes a recurrence relation so important, to have that given value. Because let's see if it changes anything up. Oh, could it possibly? Ooh, the suspense is killing us, right? Oh, you guys. 2 times negative 1, because remember, you're plugging it in. Whatever is the existing term gets plugged in. That's what changes it up. This is now equal to negative 2 plus 1 is negative 1. What? A sub 3, plugging 2 times, bringing this little feller back, right? Negative 1 plus 1. It's negative 1. Okay. A sub 4 is 2 times negative 1 plus 1. Lo and behold, is negative 1. So with this relation, all the numbers are the same. So for that particular sequence, right, all the numbers are exactly the same. And that's okay. It's okay to have all your numbers that are the same. All right, it's what happens. But I wanted to point out, it makes a difference. This is just changing a positive to a negative. If you start with a whole different number, then that would make that impact also. If I'd have started with a negative 2, right? And I plugged a -2 in there. That would have made a difference. Then I wouldn't have that number again. So that would be what? 4 plus 1 is 5. That's not the same. Then you would plug the 5 in. Do you see what I mean? So the whole point of this with a recurrence relation, those numbers that you start with, you have to pay attention to that and they make an impact. Okay?